All right, so we've got 2 hours max, and I hope there'll be less than that. Then I want to go over some code with you, then go through the lecture and the chapter. But I'm going to show you some code first. All right, so what I'm going to show you, I've given you hard copies of all those. So I want to open up my existing project here, and I got to find it. Yeah, we'll start with this. So again, these are the handouts that I've already given you, but I want to go over it, and ideally at least, what we're doing here is going to make some sense to you. All right? All right. Now, these first programs are basically the same program that's been written twice. All right? And what I have here, and again, you have the hard copies of this, these are both console programs. And good, bad, indifferent, whatever, I decided to show them to you like this, and you're getting a lot more than what's even in the chapter. Let me run this to just show you. All right, please enter a number, 23. 23 is odd. If I want to continue, type in yes, I do want to continue. 44. 44 is even. Okay, do I want to continue? Yes. 0. 0 is neither odd nor even. Does that make sense, what's going on? All right. The first question to ask you is, does it make sense that if I'm going to check if a number is odd, even, or 0, that really the first thing I should check is whether or not it's 0? Does that make sense? Because the way I'm going to see if a number is odd or even is I'm going to divide it by 2. And if there's no remainder, it's even. If there is a remainder of 1, it's odd. Does that make sense? But if I didn't check first for 0, it would say 0 divided by 2, and it would give me a remainder of 0, so it would say 0 is an even number. Does all that make sense? All right. So this will give me a chance to go through a couple things with you here. First, what I did, this isn't until the next chapter, but I put this into a loop. All right? And the reason I put it into a loop is I got sick and tired of running the program over and over and over and over and over again to check everything. So I put it into a loop. So if the loop stuff doesn't make a lot of sense right now, don't let that word, bother you. Okay? Because that's what Chapter 5 is all about. All right? And when you run a loop, just like when you run an if statement, whatever you're checking, be it a loop or be it an if statement, etc., those are all Boolean conditions. You all know that a Boolean condition is something that has to come back and be either true or false, right? Okay, so right now I've got this line here that says while again, and this is a shortcut for while again equal true. Does that make sense to everybody? That these two things are identical to one another? All right, the only reason that I left that off is it's less typing. I have never, in actual regular code, I've never seen anybody do this, other than students. And that's okay if you're doing that as a student. But you'll almost always see it done like this. So we have 3 variables in here. All right, the first one, this again, for lack of better words, that's our program control variable. In other words, that's going to control whether or not we want to run the program again. Notice that I'm giving it an initial value of true. If I gave it a value of false right here, I would never go into the loop. That wouldn't really make a whole heck of a lot of sense. All right? Then this right here where it says number, this is the number that I'm going to input. All right? And this is going to basically say, like, run program again. All right? So I'm coming in here now and I'm doing this. I want to be able to run this program multiple times. So while again, which means while again equal true, since I set again equal to true up here, I'm going to go into this loop. So here's my loop. And it says, please enter a number. Now, we went over this last time, but I want to say it again. Does this make sense? I'm asking you, please be honest. Does this line of code that's in blue make sense to you? On the screen, it comes up and it says, please enter a number. But remember, whenever you use a write statement and whenever you use a read line, it's reading it in as a string. I can't check a string value to see whether or not it's odd or even, because that doesn't make sense to the computer. So what I'm telling it to do right here is I'm telling it to take that string value that I have and I'm telling it to convert it into an integer. All right? Now the question got asked to me yesterday, and you know who you are, but as far as this goes, and just so you know, what I'm going to do is I'm going to put this here, I'm going to comment that out. But if I say convert dot, you'll know if I type in 2, notice there's a lot of things I can convert to. All right? I can convert to different kinds of integers. I can convert to a character. I can convert to a double. So there's a lot of different stuff. But since up here I said that the number I'm reading in is an int, that's why I use the convert to int. All right? And when you're not sure, you usually use the 32-bit int. What's the difference between a 32-bit int and a 64-bit int? How big the value is that you can put in there. With a 64-bit int, you can put in double the value. I'm not going to put in a gazillion here. All right, if this will hold something up to some millions or whatever, I should be fine. All right, so I'm telling on the screen, it's saying please read in a number. Since it's a write statement, since it's a write and it's not a write line, the cursor's going to sit right there and wait. I enter something, and it's going to attempt right here to take whatever I enter, and it's going to attempt to convert it into an integer. If I leave it blank, or I put in something non-numeric, or I put in something with a decimal, if I do any of those, leave it blank, non-numeric, or a float, double type of value, the program's going to blow up. Does that make sense? Because it's trying to convert it into a whole number. And I'm going to show you all three of those. So if I run this and I leave it blank and hit enter, the program is going to blow up. All right? And actually right there, it's still waiting. So I don't know why it's hung up, but it's hung up. Try that again. All right. See how it blows up? That should make sense to you. In later chapters, there is an entire chapter later on in the book that's on exception handling. Then we learn how to basically keep that from happening, period. All right, there are different things that you can do. There's different ways. I'm just going to hold off on that until that time. So for right now, we're going to assume, you know what happens when you assume, but we're still going to assume that the person running the program can put in the values, the type that we're asking for. All right, so we tell them to enter a number, and we're going to assume here, so let's say you put in 41. All right, so the first thing you say there is if the number we just put in was 0. It's 41, so that's not 0. So what that means is this is false, so this gets skipped. Does that make sense to everybody? I know you had this last semester, those of you who were in the class, in the JavaScript class, but again, we're starting brand new. All right? So if it was 0, it's going to do this, and it's going to get the heck out and go down to here. But since we put in 41, that's false, so we will not do this, and it comes down here. And it says, all right, take 41, divide it by 2, and check the remainder. 41 divided by 2 is 20 with a remainder of 1. So is the remainder 0? No. So we skip this. Does that make sense? All right. Since this was false and this was false, we come down here and we do this. I don't have to check anything anymore. It has to be an odd number. It can't be 0 and it can't be even because we already checked that stuff. So all I do is I come down and I say the number, remember that's a placeholder, so that would say the number 41 is odd. Does all that make sense? Again, if I run the program and literally put in 41, it's exactly what I'd expect to have happen. And it does. That's good. So it does all that, and then it comes down here and it says, okay, enter yes to the question below to continue, and anything else to quit. And I kept it real simple. So I said, this is where the system is waiting for you to enter yes. I didn't use too upper or too lower or anything. So it is assuming you're going to put in an uppercase Y followed by a lowercase e followed by a lowercase s. Does that make sense? All right. And you know that's a string because it's in double quotes. So if it's not equal to yes, so if I put in anything other than uppercase Y, lowercase e, lowercase s, then it's going to set again to false. And what happens is it comes back up here. And if again is false, boom, I get out. But if I did type in YES, it's still true. So it's going to come down and ask me to put in a second number. This time I put in 0. So is the number 0? Yes. So it writes the number 0 is neither odd nor even. And once you find a path in here that's true, you skip the rest. So it skips all of this. It's just done. It doesn't do that. So it says the number 0 is neither odd nor even, and it asks if you want to do another number. So we put in yes again, and it comes back up and it asks us for yet another number. And we put in 64. Is it 0? No. Is 64 divided by 2 come out evenly? Yes. So we come in here and we do this. So we print out the number 64 is even. Does all that make sense? So what I just ran through with you was what happens if we put in invalid input. In this case, we're not handling it, so the program blows up. Then I showed you what happens when we put in 0, what happens when we put in a negative number, and what happens when we put in a positive number. All right? So again, if I run this and I put in 0, neither odd nor even, yes, I want to do it again. 33, odd, yes, I want to do it again. 64, even, do I want to do it again? And just so you see this, since it's looking for uppercase Y, lowercase e, lowercase s, if I put it all in lowercase, the program stops because I didn't meet the criteria. Does all that make sense? Is there anything we just went over that doesn't make sense? Yes.
So on line 33, you have just right instead of right line. Is that
right here? Here.
Well, yeah, there too, I guess.
Okay.
Is that just where?
That typically that's a prompt right there.
That's what I was asking.
And then when it's a prompt, you typically want it to stay on the same line. It wouldn't have hurt to make that a right line, but then please enter a number. It would have dropped you down to the next line. That's all. Any other questions? Now this will not be on the hands-on test that you take tomorrow, but you will take a hands-on test next week, and this will be on there. You will have to understand how to use an if statement. That's why I'm saying if it doesn't make sense, now's your time to ask. And notice, and Brady, you weren't here yesterday, but I want to just bring this in here so everybody can see it. I'm going to copy this. Yesterday I told everybody about this site that I found, and actually I knew about it before, but for whatever reason I didn't show it to you. I'm going to tell you about that too. So if I come through here and I type in learncs.org, that's the name of the site. All right, it literally shows you this, where you can basically build yourself a little console app.
Oh.
So what I'm going to do is I'm going to grab everything. I'm going to remove this console.writeline from main. I'm going to put in my stuff into main, and then I have to add at the top using static system.console. And the nice thing about that is now I can come and I can run this. Unexpected symbol in a file, which means that I'm missing a curly brace. Well, now I really screwed it up. You get the idea, though, correct? So you can run it on there. I don't know what I did wrong, but evidently something pretty bad. I can always try to do this. I can go into here, try to copy my whole project. bring it back in here, paste in the whole flippin' project. Well, like I said, something is screwed up, but it will work. Okay? All right. Now if you go and bring up the other handout that I gave you today, all right? I've written this odd and even program twice. I wrote it one time where we used an if, and I wrote it again, and I used what's called a switch statement. All right? Again, I realize that some of you are struggling with this stuff. All right? I've had emails from people asking for extra resources, etc. Okay? And the best thing that I can tell you is this book is really a good resource. I'm not saying it because you've got it. I'm saying it because it's a good resource. So if you're getting stuck on this stuff, I would recommend that when the author puts programs in here, that even, and she gives you all the code, to key it in anyway and look at it. All right. Now this program is similar but not identical to the last one. Okay? Now I've got that Boolean variable again, I've got int number, and I've got string another. Okay? And I've got it in a loop again, exactly like we did before. All right? It says, please enter a number. All right? So, right here, this looks a little weird. I think it does at least. Because what the system does is it takes everything on the right-hand side of the equal sign and it evaluates it. So it says whatever number you just put in, take it, divide it by 2, and check the remainder. If the remainder is 0, then it's going to assign the answer true. If the answer is 1, it's going to assign the answer false. Does that make sense? Okay. I could have, and maybe it would have made it a little easier, I could have put this in parentheses. It will work the same way whether you have it in or you don't have it in. All right? But this will now either be a true statement or it will be a false statement. One or the other. All right? So I switch on it. If it's a true statement, I say that it's even. If it's a false statement, I say that it's odd, and there's a default there that says it should never be hit. Now, the only problem with this program, the way it's written, is that. Okay? Because remember last time we wrote down 0 is neither odd nor even? So, how do I get around that? Well, one thing I could do is before I even check this out, before I even do this, I could say if number equal 0, again, I would come in here then and I would do a right line and I would say 0 is neither odd nor even. All right, I can do that. Then, so after I've done all that, I can say else. So does it make sense to you that if I get down to where this says else right here, if I get down to here, the number can't be 0? All right, so then I just take all this stuff that I put in here, everything. I'm going to just tab it all over so it looks a little better. Now, is this perfect? No. Did I make it better? I hope so. All right, so all this stuff with that else, that's got to go to right here. All right, hopefully I did that right. We're going to find out real quickly. So if I do this now, if I come in here and I put in 0, 0 is neither odd nor even, and it asks you to continue. All right, yes. Enter a number, 45. It's odd. Do I want to continue? Yes. 100. Whoops, 100. It's even. So it works. Okay? Sometimes the hardest thing to do as a programmer is to try to figure out This is going to almost sound counterintuitive, but when you're writing an application for people, sometimes what you want to figure out, you want to break your application. Now, does that sound a little weird? But if you write an application, you want to break it. Why do you want to break it? Better you than when it goes out on, when it goes public. And maybe I told you this story last semester. If I did, I'm sorry, but I still remember. My student, Jeff Davenport, he comes in on a Monday morning. I'm teaching in Stevens Point, Wisconsin, and he's like, man, I worked all frickin' week, he didn't say frickin', but weekend on this program, and it works 90% of the time, but I worked so hard on it, I think you should give me an A anyway. So I looked at it. I could really very quickly tell him what the problem was, but I wasn't going to. I wanted him to find it. So I said, you think you deserve an A for this? And he said, yeah, for all the work I put in on it. I said, okay, what would happen if you marketed this product and you used that for your slogan? It works right 90% of the time. And he said, nobody'd buy that. And I said, you just asked me to. You see what I'm saying? He thought I was trying to be a smartass. I wasn't. I was telling him that if you are going to create a software product for someone, they don't expect it to work right 90% of the time. How often do they expect it to work? 100% of the time, or every time. All right? And they expect you to handle things that, any kind of glitch. Right now, this is not a glitch-free program. You've already seen that if we come in there and if we put in a non-numeric value, the program blows up. But what I want you to understand is in this case, rather than using an if, we're using what's called a switch. Okay? Now imagine that we wrote a program, and this might even be on your next test. I don't know, I don't remember what your next test is, the one on 3 and 4. All right? But let's suppose I asked you to write a program where you entered a grade, and the grade had to be between 0 and 100. If it was 91 or above, it was an A. Okay? Or 90 and above was an A. 80 to 89 was a B. 70 to 79 was a C, etc. You all get that? That makes sense? All right. I wouldn't want to write that as a switch. When you write a switch, you've got to write every possibility. So I'd have to write case 100, case 99, case 98, case 97, you see what I'm saying? I'd have to write 100 of these. Really 101 from 0 to 100. I don't want to do that. Then you use an if. If you only have a few possibilities, all right, and what's few? It depends, all right, then you do something like this. But you're working with literal values. Here it actually makes a lot of sense to use a switch because there's only true or false. And if works just as well. All right, I'm not sure what Evan has written for that next second test. I will look at it. I'll let you know before the test. But to my knowledge, I don't think he wrote a test where he said, you got to use an if on this one. You got to use a switch on this one. You will go through this, and with one of these, you will probably develop more of a comfort level than with the other one. All right? The other thing, too, and we're going to get into this because we're almost done with this. We're going to switch back to the book in a minute. But if I want to see if something is inclusive, all right? So if I told you to enter a grade, and I want to check whether or not the grade is between 0 and 100, all right? I'm going to say then if grade greater than or equal to 0, and I'm going to put this down here, grade less than or equal to 100. Does that make sense to everyone, what I just put there? When you're saying and, both the conditions have to be true. So we're saying that this has to be within this range. So if you're seeing if something falls within a range, you use double ampersand. That means and. All right. On the other hand, if I wanted to check for bad grades, I could say if grade less than 0, or, that's a pipe sign, grade greater than 100, all right, that would mean if this is the case or this is the case. Sometimes what students accidentally write down is this. What's the problem with that statement? Can somebody tell me? Right there. They both have to be true and? Is it possible? Okay, it's not possible. That's never going to be true no matter what you put in there, because a number can't be, it can't be both less than 0 and greater than 100. So if you're trying to see if something falls within a range, you use and. If you're trying to see if something is outside of a range, you use or. All right? And it's important that you realize and recognize that. All right? These are your relational operators. So it's a double ampersand is and, which means both conditions have to be true. All right? If it's a pipe sign, a double pipe sign, it's an or, which means if this one or this one. Sometimes you'll use an or and they can both be true. That's okay. All right? Now, I don't know, do you have to take a math class here while you're here? I have no idea what that math class is about. I think that somebody told me that you do a little bit of algebra and stuff. But the point is, at the school I used to teach at, there was a class that was called DP Logic, Data Processing Logic. And you would go through this and you'd literally write what are called truth tables to show how all this stuff was set up. I had to do that when I took the class. When I went on for my master's, when I decided I wanted to go and take a couple classes in architecture, I had to literally, they gave us the old Heath kit, and I had to wire up what were called AND gates or gates. And then somebody had to touch them with a sensor, and if I did it right, this would light up and that wouldn't, or that wouldn't light up and that would, type of a thing. But that's how computers operate. Because what's going to happen is, with the AND, okay, they have to both be true. If either one of those is false, you don't do it. When an OR, you do it unless they're both false. All right? And the only other operator that you have to worry about is this one, which is not. All right? And basically it's called the inverter. So not true would be false, not false would be true. All right? Oh, one last thing. What C# does, and most languages do this, Java does it too. They do what's called short circuit evaluation. What does that mean? All right. That means if I've got a condition, I'm going to erase this, we don't need this. But if I've got a condition like this, I'm going to say, here, I'm making this up, so hopefully I'll write it okay. Int x equals 7. Int y equals 10. Int z equal 12. So if I put in here, if x is greater than or equal to 6, or y is less than or equal to 1. Okay? What short circuiting does is it says, okay, it's an or. So I check this first one. I'm asking you, is that true? Is x greater than or equal to 6? All right, it's 7, so that's greater than or equal to 6, right? So it doesn't even check the second one. It doesn't have to. That's the short circuitedness. It says, I don't even have to check this because that one's true. So if you're going to write a condition like this is called a compound condition, where you're combining two conditions. You always take the one that's most likely to be true, or true if it's an or false if it's an and you put that one first. All right? Just the same way if I do this. So that's an and. And let's say that instead of this, if I said it was greater than or equal to 9. All right? Well, that's false because 7 is not greater than or equal to 9. So it skips that one. Okay? And I think that's on your test. Again, it's referred to as short circuit evaluation. So I know we did that fast. And it's important that you understand some of the syntax and the like. Charles did tell me he's going to look for a new chord for this today. But so you know the if syntax. With a switch, you say switch, and then you have to put in parentheses what you're switching on. This is like what you're ifing. So this, in essence, what you're doing right here is what you're saying in the blue. That's substituting for if answer equal true. Does that make sense? And this one with the switch here, and this one is saying if answer equal false. That's what you're doing. All right, the whole thing has to be put inside of curly braces. and you say case followed by something in a colon, and then you do whatever it is you want it to do, and you need the word break in there. If you don't put the word break in, it just keeps falling through. So if you didn't have a break right here, and let's say that we put in 10, it would say the number 10 is even, and it would immediately fall through and say the number 10 is odd. If we didn't have another break there, it would say the number 10 is even, the number 10 is odd. This should never be hit. So you always need a break at the end. All right? And it's not mandatory that you put a default in. Most people do. Most good programmers put it in. Even if it's to put a message like I put in there that says this should never happen. All right? Okay. I'll go till 8:55, so I'm going to jump back into the book. And at 8:55, we'll take a break. And I don't know, maybe it made more sense to do it this way, maybe it didn't. But a lot of the stuff that's in the book now, I'm just going to buzz right through it. Because the author gives her take on these, and I didn't really like most of her examples. What's that? Yeah, from what I hear, at 10:30 they're coming. At 10:30, I think it is, we're all going to go over to the classroom next door. So that was 3. That's what we did yesterday. All right. So I'm on page 137 in your book, Making Decisions. So here's our chapter, whoops, that's not good. Here's our chapter objectives. Understand logic planning tools. They're going to talk about 2 different things. One that's called pseudocode and one that's called flowcharting. We'll talk about them in just a minute. Next, learn how to make decisions using an if. You've already been exposed to that a little bit. Learn how to make more complex decisions with if-else. Using compound decisions, which is what I just showed you. Making decisions using switch, so I showed you that. I didn't show you the ternary operator yet, which is the conditional. We'll go through that in just a minute. We actually did do an example of that last semester in JavaScript, and it'll be the exact same example that I'm going to show you. All right? I mentioned the not operator to you, and some of those common errors when making decisions, that's why I showed you about when to use and when to use or. So you've already had a lot of this stuff in here. All right. Many people, when they start writing code, start by writing what's called a flowchart. And this is an example of a flowchart right here, albeit a really bad one, but that's a flowchart. In other words, what you have there are graphical symbols that you use to show that things are happening, okay? And what I'm about to show you, this will mean nothing to you. I understand that. Oh, where is it? There. This was back in when I was going to say when I was your age. I guess it was pretty much when I was your age. And I was taking this stuff. This is something everybody had to have. It's plastic, and it was a flowchart template. We had to actually buy flowchart paper, and we had to go in and we had to flowchart, and we had to show our flowchart to the instructor before we could start writing code. Because the instructor had to sign off and make sure you understood the logic of the program. What a flowchart does is it shows you the logic of the program in a pictorial type of way. Does that make sense? These symbols all mean different things. For instance, this is a decision symbol right here. That's if you use an if statement. You know, something like, is it raining today? Yes, I would maybe go down and do this. Or usually a yes, I would say yes, get my umbrella. No, don't bring the umbrella. And then I would bring those 2 down together here. Now, do you need to care about that? No, but I just want to show you that. Personally, I think that in some ways we need more of that. Because with IDEs and with everything you've got, people rush to sit there and write code before they even understand what it is they're trying to do. I had a student many years ago, it was one of the first times I was teaching, and it was about the 3rd program, and it was the first hard program the students had to do. And I noticed that, you know, I gave them the assignment, people are sitting there and they're keying stuff in and they're doing this and they're doing that, and there's a woman, she's just sitting there like this. And she came up to me, and this is going to sound like a weird story, but she came up to me and she said, "Can I ask you a question?" I said, "Yeah." She goes, "Would you mind if I went to the library for maybe a half an hour?" I said, "Why?" And she said, "This is a hard program, and I want to make sure I understand what you're asking for." And my response floored her because I asked if I could hug her. She looked at me weird. I said, "I don't mean it literally," but I stopped the class and I said, "Okay, there's 20 of you in here. 19 of you are coding right now, and my guess is half of you who are coding don't understand at all what it is you're supposed to be doing." One person who said they wanted to take some time to make sure they understood the requirements. Your requirements are what you're asked to do. Your design is basically how you're going to do it. Does that make sense? So the requirements should always drive the design. Does that make sense? What happens when you start working on a program before you understand the requirements is the design starts to drive the requirements instead of the requirements the design. So if you're really stuck and you don't know where to start, and you don't have to do it with a flow chart, all right, again, there's other ways that you can do it. You can use something that's called pseudocode. And I don't think that's a little better flow chart that they're showing you right here. Again, there's an example of a decision statement. These are basically processes, so that's something that you want to do, all right? But the other thing that you can do is you can use something that's called pseudocode, and for whatever reason, they're not mentioning it in here, so. So here's an example of how you might, that's not a good example. There. That's an example of how you might do something right there with pseudocode. You're not going to be able to type that into a computer and have it work because, for instance, there's no statement in that language called and do. But what you're doing is you're using an English-like structure to explain what the program is trying to do. And the advantage of using something like pseudocode, it's not language dependent. So you could, if I know 10 languages, I could take that pseudocode and put it in any of those 10 languages. But again, people just today, for whatever reason, just rush to try to get something done. All right? So especially if you're stuck on something, sit and think about it for a while. All right. Now, I didn't show you this, but if we wrote, for example, and it's 8:50. As I said, I'm going to give you a break at 8:55. So if I came through here and did this, okay, I have to make this big, otherwise you're not going to see it. All right. So if I came in and I said int age equal 21, and I said if age greater than or equal to 21, right line, legal. All right, in fact, let's make this a constant. Oh, we'll do this, legal equal 21. Const int legal equal 21. Int age, we'll say equal 18. All right? What's going to happen right there? And this is not meant to be a trick. I'm asking you, is the age greater than or equal to 21? Is it? Okay, so what do you think is going to happen? Sounds like a trick question. Nothing. If you use an if the condition is true, you do what you put in between the curly braces. But if there's no else, you just skip it. Does that make sense? So there, it's going to put in legal. All right? But as we said before, there it's not. So if you have an if, this is a Boolean condition. This is something that the computer has to be able to tell it's true or it's false. And if it's true, it's going to go and do whatever in here. And if it's false, it's going to skip it. Does all that make sense? I mean, it's, when you listen to it, you're like, well, of course it makes sense. It makes sense. Okay, fine. But if I come through here and I say this, and I say else, steal some code here. All right? Now it's going to come in and it's going to write not legal based on what we have. Does that make sense? All right? Let's suppose that if for some reason, if you were 21, let's say that it had to be greater than 21. But if you're equal to 20, if you're 20, all right, for some reason you're handled differently. Okay, I don't know why you do that, but we could say here, else if age less than 20. Do this, else, I don't even care what. Just do something else. What I'm trying to get to is I can account for anything I want to. So I can say if this, do something, else if this, do something. I can have as many of those else ifs as I want to have. But if I'm going to put an else, I can have only one else. And it has to go on the bottom after all the else ifs. If you think about it, that should make sense to you. All right? So the first thing that they talk about then in the chapter right here is they talk about just an if. Where they say test an expression, the idea is it's a Boolean condition. Okay? She shows it to you pictorially. All right? And then she mentions how this is a block. If you only want to do one line of code, you don't have to use the curly braces. Did you hear what I said? If it's only one line of code here, you don't need the curlies. Everybody that I know that's a professional programmer, even if it's only one line, always puts in the curlies. Whether it's one line or more than one line. If it's more than one line, you must use curly braces. If you want to put more than one line in here, you must do that. All right? Okay, before we go into nested ifs, let's take a break. All right, so let's come back. We'll give you a healthy break. Let's make it 10 after 9.